This is day 19 of doing Leetcode 75. We're doing 2095, which is delete the middle node of a linked list. So you're given the head of a linked list. You have to delete the middle node in order to return the head of a modified linked list. The middle node of a linked list of size n is n divided by 2. That node from the start using zero base index, where the that element is, or that node denotes the largest integer that's less than or equal to x. So for 1, 2, 3, 4, 5, the middle nodes are 0, 1, 1, 2, 2, respectively. 1, 2, 2, yes. So for example 1 here, we go all the way till 7, and we want to move the node behind it, its next value, to be 1, and essentially we're getting rid of that that reference to that 7 node here. So it plays no relevance inside of our linked list. So the way that we can do this is by making use of we understand that when you have when you are using linked list pointers, you can have a slow and a fast pointer. The fast pointer will try to go to the end of the list, and you'll have a slow pointer which goes to half of the list, because let's say that when you're going through the entire list in 2 times speed, and you have a slow pointer that's kind of tracking behind it, it's going to be 1 times speed, so it's able to get the middle of the list for you, and then you just need to get the node that's previous to that middle node, and then point that reference to the next value in the linked list. So yeah, there's no exact previous pointer, but that's how we are able to get the node behind the middle node, essentially. So we can instantiate 3 variables here. So one's going to be the previous slow, the actual slow, and the fast, which is none, head, and head. We say while fast is not equal to none, and fast.next is not equal to none. What we're going to do is we're going to have previous slow equals to slow equals to slow.next, and we'll have fast equals to fast.next, so it moves in 2 times speed. Then we'll have previous slow.next equal to previous slow.next is equal to slow.next, and then we'll return the head, and that should be the solution. Previous slow.next is equal to slow.next. I don't think it's dot next, right? And then we'll say that if head is not equal to none, or dot next not equal to none, return none. Wait, oops, sorry. Yeah, and that should solve our issue right there, because this code doesn't account for the fact if there's only 1 node in the linked list. So we just need to get rid of that using our initial condition here, and we have our previous slow, which tracks the element that's behind our 1 time pointer. We have our 2 times pointer here. I like to think of these as the speed of how they go. So yeah, this one moves in 2 times speed, this one moves in 1 time speed, and this one just tracks the node behind that 1 time speed pointer. Then we just move that next pointer for the node that's behind the middle node to the middle node's next node. Hopefully that's not too confusing, but yeah, that's how you solve this problem.